I will explain the a leader election process in RAFT, but before I do so, I want to say state machine replication in RAFT needs or requires n greater than or equal to f plus 1. So n is the total number of servers and f is the total number of failures. So if we assume we have 2 failures, so in the system we need n greater than or equal 5 servers. So the server states in RAFT are 3 things: follower state, candidate state, and leader state. So the leader will be in one of these states in any time. To elaborate on that, so let's take this figure. So we start, all servers start in follower state. Then when waiting time expires, each server or a server will flip its state from follower to a candidate to start a new election. Then it will increase a term number. I will explain what is the term number later. Increase its term number and broadcast a vote request for all servers. Upon receiving a majority votes, it will change its state from candidate to a leader. Or if there is no majority, if the server did not receive the majority, it will time out, then it will start a new election. Or it will discover current leader or a new term, then it will change its candidate state to follower state. Then if the server state is a leader, it will be a leader for some time until the leader discovers a server with the higher term. If it's discovered server with the higher term, it will change its state from a leader to follower. So this is only the all possible states for server in RAFT. So the timeout, or sometimes they call it election time, every node will wait until its time expired. Then if the node did not hear from current leader or a new leader, it will change its state to candidate and start asking for a vote. But this time it's a random time. So this waiting time, it's a random time. I'll explain it later. I think it's from 150 millisecond to 300 millisecond. So randomly, every node will pick a number from 150 to 300. So all of them in suppose we have a 5 nodes, all of them in term 0, and everybody has a random number or a timeout. But this one has a lowest timeout, which is a 150. So if the timeout is expired without hearing from any leader, it will increase its term, change its state to candidate, and start sending a vote request to other servers. Upon receiving the majority, it will be the leader and lead the system to reach agreement. So in RAFT, we talked about terms. The terms, it's a period of time, but basically it's just a number. We call it a logical time. So the logical time here is just a sequence number increase monotonically. So it's just an ID. For example, if it's just an ID or the integer, and but the representation for the terms, it is arbitrary length. It's a period of time, and this period of time has two parts: election part and normal operation part. In this figure, this is the election part, and this is the operation part. The election part, when the servers trying to win the election and become a leader. Once it's become a leader, the normal operation part is the agreement and execution. So all servers will try to reach an agreement on the client request and execute that request in this part. And there are some part of the term will be large, some part will be small. So it based on how fast will servers will reach the agreement and or reach the consensus. This one, there is no leader. I think there is a failure in, not failure, leaders try to receive a majority of from other leaders based on the votes that he sent, request votes, but this leader did not achieve the majority, or not acquiring the majority, and there is no leader for term 3, and the new leader came with the term 4. Yeah. Or maybe there are so many things, there are so many interpretations for this. And the term also can use to detect obsolete information. For example, if there is a node locking behind and it has a lower term, so that node state has a stall state, means all the information, the log for that node, it's not up to date, so it has a stall state. So that node has to detect the higher terms, higher number, and update its state. So term helps to detect the nodes who are locking behind. I think this is okay. Then to keep leader and follower in sync, leaders send periodic heartbeats. This message, it's a message. Periodic heartbeats, I mean a message. Message in RAFT is just an empty and binned entries remote procedure calls. It has no log, but it has the term number and the index number. So this message is a regular message, or regularly the followers has to receive it from the leader. If in case that the followers did not receive the periodic or the heartbeat message, the follower will assume the leader is dead, or there is a network partition, or it's not active anymore. So what the follower do will wait for election timeout. The timeout I explained already here. This timeout. They will wait for it to be expired. Then they will assume the leader is not available. Then they will start a new election to choose a new leader. About the terms should be sufficient to make a progress, or to make sure the leader is not active. So this term should be sufficient. To make a leader election and to reach a consensus on the value. So this paragraph is the same. It's just the same for this figure. I already explained it before. It's the server states, but there are issues. So there could be multiple election in the system. Node by design can vote for itself and starts gathering majority votes. It's possible that none of election win, so nodes stuck in the election loop again and again without a leader. So the solution for a multiple election is a randomized timeout. The timeout to wait before starting a new election, because if every node has a different timeout, but there is a minimum for it, so eventually one will win the election, because if they have the same time, everybody will cancel each other, I guess. So here this helps. I mean, the randomized timeout helps to reduce the probability of election collusion. In RAFT, there is also a multi-leaders problem. It happens because of the network partition. We can have a multi-leaders in RAFT, but without a majority because of a network partition. So if you have a set of nodes, maybe you will say 6, and this is the leader, but this because of the partition, a new leader came in, leader 2, to this one. This one still send a heartbeat message to this node, so it's still alive, but they can't reach any majority. They can't reach any majority, so they don't serve any right. Maybe read, yeah, maybe if there is a client, the reading operation, this partition will serve reading operation, but it's stall information. So there is possibility there will be two leaders at the same time. I think that's it for leader election, and I will continue with the log replication in the next video. Thank you.